And welcome to this webinar. We're very excited today to be talking to everybody about. I think one of the really interesting topics going on is the merging or the convergence and cooperation between game engines and engineering software for digital twins. Very great panel that we've got started for you. We are recording this just to let everybody know. And also would love for you to be putting your questions in the panel. Please, at any time, feel free to go ahead and put a question in, and then we'll be getting to as many of those at the end of the webcast as we can. And for those that we can't get to, we'll try to make sure to follow up with you directly, depending on who you direct the question to. I'm Jim Brown. I'm president of Tech Clarity. I'm moderating. This is the fifth of this AMC Bridge series. Executive series, which is just fantastic. AMC Bridge has been great in terms of organizing these and bringing together a fantastic audience. So thank you for that. And with that, we'll get started. I'm going to have the participants introduce themselves more directly, but just a quick welcome to David Weir-McCall, Erin Khan, Elizabeth Barron, and Igor Tsinman. So I'll be your moderator today. Again, I'm president of Tech Clarity. We're an independent research firm that focuses on product innovation and engineering for both the manufacturing and the AEC industries. So with that, I'm going to go ahead and have each of the speakers introduce themselves. And what I'd like you to do is share a little bit about yourself and then a little bit about your company. So David, I'm gonna start with you, if that's okay.
Absolutely. Great to be here. My name's David Weir-McCall, and I work with Epic Games. A little bit about me. I come from industry, so I'm an ex-architect. Spent a good chunk of my career out in the Middle East working on super projects, and recently I joined Epic Games to kind of help support the kind of growing community around using game engines, but within the AEC itself. So Epic Games is the provider of these real-time engine or game engines, as we're calling it in the webinar today. And it's amazing seeing all the different avenues and places that these game engines are taking place and exploring how to solve problems within the industry. And one of the ones I'm very excited to chat about today is around digital twins.
Great. Erin, I'm going to move to you. If you can give us a little bit about your company and then yourself, your company, and then your role with digital twins.
Alrighty, thanks, Jim. Happy to be here. So my name is Erin Khan. I'm the National Director of Construction Solutions with Suffolk Construction. We are a national general contractor, so the core of what we do is build buildings, but we like to do that in a smart way, an innovative way. So we approach the built environments through the lens of invest, innovate, build. So we have a Suffolk Technologies group that invests in some of the latest technologies and startups that are coming into the market. We use those innovative tools approaches such as digital twins, for example, which I'm sure we'll get into, of course, today, to make that more effective and efficient. And then my role is to implement those tools and track how successful the outcomes are with our operational teams. I've been in the industry about 10 years or so, started on the build side, but am now heavily into the process and technology side.
Very good. Thank you, Erin. Elizabeth, if you would introduce yourself, your company, and a little bit about how that applies to digital twins.
Yeah, hi, my name's Elizabeth Barron, and I'm a senior manager for enterprise solutions at Unity Technologies. So Unity is a game engine similar to the Unreal Engine as far as the game engine tech goes. And so my role is to look at how the game engine can be used as a framework to provide 2D information and 3D information, pairing those two and looking at it from the digital twin perspective to provide a multitude of data that can be consumed and understood in context. So it's more than gamifying the manufacturing process or construction process. It's really about how to get information provided that's relevant when you need it. So I also have an immersive background, so very similar to David. It's kind of cool. And I love all things immersive. And the other good thing about game engines is the platforms that they run on, from your mobile to the most heavy duty immersive workstation in VR. So yeah, that's me. Thank you. It's nice to be here.
That's nice to have you, Elizabeth. Igor, if you would introduce yourself and AMC Bridge, and then also a little bit about your role with digital twins.
Sure. Igor Tsinman, president of AMC Bridge. AMC Bridge is a custom software development company that is working in manufacturing, construction, and architecture area for the last 20 years. I kind of would like to say that digital twins and game engines is kind of personally very interesting for me. I started my career in software developing simulation models, and at that time it was very fun if you know and able to look at the digits on your screen, but without much of a graphics, it was very hard to explain to people. And I think the combination of game engines and data is what makes me excited about new stage of digital twin development and simulation development, etc. So at the AMC Bridge, we see more and more requests from people to build digital twin or software to support digital twins, and I think this is very exciting and hot area of the development and for the industry as well.
Yeah, thank you, Igor. Thank you. So let's talk a little bit about the importance of digital twins. I mean, there's clearly a lot of buzz about digital twins, and you can't look at LinkedIn and somebody's got something to say about it. And our research shows that the majority of companies view digital twins as either important or critical to their business strategy. So they clearly are not just not just a passing fancy or something like that. But where are companies with it? Are most companies still experimenting with digital twins, or are we beyond that? I mean, what tangible business value do you see companies actually achieving now from digital twins? Igor, if it's okay, I'm going to start with you on this one.
Well, we are kind of on the receiving end of it. We are not setting trends, but we are observing it by the way of talking to customers and receiving requests. And I see that lately digital twin is of great interest to our current customers as well as kind of prospecting customers. And I would also think that it kind of resonates better with construction and architecture kind of customers, because digital twin, you wouldn't create digital twin for a bracket that is manufactured in thousands and thousands, right? You have to have some valuable assets to invest in creating of digital twins, and buildings and especially kind of infrastructure objects are kind of prime target for creating of digital twins. So I don't have exact numbers, but Erin and I attended the Build World conference lately, and they had some surveys. It definitely on everyone's mind, but the stage of implementations and stage of adoption is different. And I don't have a clear picture, but I still think it's the early adopters are pushing ahead, and other ones kind of observing and exploring and kind of sitting and waiting what happened to early adopters. I think it's still in infancy, but my hope that game engines would add a little bit of buzz to it, a little bit of oomph, and kind of we like what we see, right? It's all good when people talking about, but when you see and you can manipulate it, that's very important part of the adoption, and especially C-level.
Great. Erin, you're on the front lines of this, being in the construction industry. So why don't we go to you next on this? What are you seeing as the value that companies are achieving, either your own or others?
Yeah, I think it depends in a couple ways how you define digital twin, which we'll probably get to. But if you know, we take what we typically think of as a digital twin, I really think the value is in predictability and the ability to plan. And that's, you know, really on the build side. And then on the flip side, let's say, you know, that digital twin is an asset, right, that you want to hand over to your client, owner, facility, maintenance team to be able to manage that, you know, the building, right? So it's really about planning, predictability, and management efficiency. There are many, many ways like that value is driven from a digital twin tool. So that's really where the value lies from my perspective.
Yeah. Oh, thanks, Erin. And it is interesting, that life cycle perspective. I think we've seen that AEC in our architecture, engineering, and construction now becoming sort of AECO and adding the operations side on it.
Mm-hmm.
And digital twins are very interesting there as well. Elizabeth, let's go to you. What are you seeing as what companies are achieving with digital twins?
So I think companies have for a couple decades been interested in digital twins in some way, and depending on the size of the company and their adoption of technology. I think that there has been attempts to do digital twinning using CAD data with CAD tools, and it's met with a degree of success for sure. And so I think out there now in industry, in automotive, aerospace, you know, transportation of all kinds, AECO, there are partial digital twins that are implemented. And the partial aspect of it is really because it's very hard to bring all of the data that is needed to make a decision, which Erin was talking about. That's a very difficult problem because most of those the data that you need to make the decision is in different systems. And so unifying them is kind of where the industry is going. But I think right now in automotive, in construction, like in heavy equipment makers, I've seen very good progress in the digital twin space using basically a foundation of CAD to create a digital twin. And then like what we're doing with Unity is moving into all of those other areas where there is data that isn't necessarily pure CAD data, pure 3D data, but important data that needs to be understood in the context of a lot of other data. So I think we're getting there. The value is known and understood, and you know now is the time. So it's pretty cool.
Yeah, there's a lot of work to do. Dave, if you'd like to jump in on this one.
Yeah, I mean, what's really interesting to look at other areas or other industries where digital twins have been around for a long time, and the kind of drive that they're doing and the benefits that they're benefiting from. And I always go over to the energy industry because they have been using digital twins for a long time. They've also been adopting 3D digital twins for a long time as well. And the biggest tangible benefit, which we're constantly hearing from them, is the operational aspect and the performance of their assets. And the reason why these digital twins are evolving much more aggressively in those spaces and are doing a lot more is because the ROI is so critical. You know, if you take an oil refinery and it doesn't work or stops working for a couple of hours, how many millions is lost in production? So the importance around visibility of operation is just an absolutely huge element of it. And I think that is equally as important in the AECO sector. It's just the return of investment on getting those quick turnaround feedback decisions. They are important. They're just not millions and millions of dollars unless you look at the construction process where you can save millions and millions of dollars. The other area I would call into sort of consideration here, just in terms of value of digital twins, is the visual side, which obviously me and Elizabeth are going to talk a lot about. Because there is this element where being able to see and understand that model is important, not just from an operational perspective, but from a stakeholder, from a consumer, from a variety of different areas. A couple of examples you could think of are, I don't know if anyone watched the NASA Mars landing a couple of years ago. There was this very rudimentary but pretty not bad 3D model of the pod as it was approaching the atmosphere and going down. And that in its very essence was a digital twin, because it was responding and showing how close the pod was getting to the surface. And the entire world tuned into that and watched it. And the reason that that was used as a kind of visual cue was because they needed community understanding and buy-in of a very complex process that if you were to show them some Excel charts or some rudimentary CAD, it really wouldn't have stuck or communicated as well. And we see this across the board whenever we even look at automotive and the HMI industry, where the kind of dashboard of your car, there's this new age where cars are getting these sort of visual game engines to represent that dashboard, which is live data from your car visually represented. That's a digital twin. It's just not called a digital twin in automotive. So again, the experiential visual side of it in terms of buy-in is important as much so as the operational side.
That's great. I guess when you talk about remote monitoring, that's about as remote as you get when you're doing space landings. We have a poll question. If I can ask our team to go ahead and share the poll, and then I'll ask each of you if you could just take a minute and let us know. We're looking for your experience with digital twins. You know, have you implemented them and you're gaining value? Have you implemented them but not gaining the value that maybe you had hoped? Do you have plans to implement? No plans, or maybe you don't know, or if you're you know, a consultant or something like that, let's go ahead and just have you put I don't know. Let's have this for people that are you know, in the you know, in the manufacturing or AECO industries. All right, I see a lot of good votes coming in here. I appreciate your participation. We're going to give people just another few seconds because I see that they're still coming in. All right, this is going to challenge my math a little bit, but let's go ahead and share these results. What I'd love to do is take out the those that say they don't know and only look at the other 64%. But I think what you clearly see is that 29%, just about half of those, have implemented digital twins and are gaining value. Fortunately, there's actually not that many, only about a quarter as many as that are gaining value that have implemented and getting little or no value. So I think that's actually very positive. And then another you know, another 18% overall saying that they are looking to implement it, and then a number with no plans. I'm encouraged by that. I think it's exciting to see the ability companies have had to get them implemented and get them going. So thank you for that. Let's turn a little bit to digital twin requirements. You know, so we've started looking at you know, we're seeing a lot of software vendors that have high-end visualization and modeling that are calling just the visualizations digital twins. And in some case, those digital twins put a lot of data into context, put it into that 3D context, maybe put it into the 4D context even of time. And clearly that plays a role, but other people might say that a digital twin, unless it's got some level of simulation, analysis, and decision making, where it actually is you know, the twinning is not just a display of information, but actually a what if, and the ability to understand, you know, what would happen to that lander if you know, if something happened, and how would you correct for that. So what's the difference between a digital twin and a model or visualization? And is a model or visualization enough to meet the potential value of the digital twin? Obviously, there's some value. I'm actually going to have this go to Erin first, please.
Yeah, sure. So this also goes back to what I was mentioning earlier on. It kind of depends on how you're defining digital twin, on what the value is that you're getting out of it. From my perspective, just having a model isn't really enough to quite get you there to digital twin. You know, your BIM model, it's really just like hitting print on 3D and a snapshot in time. And buildings, even though we don't traditionally think of them this way, they actually are like living, breathing, constantly changing things that we need to manage. So to me, it really takes the integration of something like IoT sensors, real-time feedback from your equipment that's in the building, to be able to have that data in that model so it's live at your fingertips. And then again, it ties back into that whole ability to simulate, which then drives that planning, predictability, and management drivers that I kind of brought up earlier as the value. So I don't think we quite get there with just a 3D model. It really takes a little bit more of that live data layer to make it something that's really in that true digital twin space, from my perspective.
Great. Igor, I know you get to hear a lot of interesting requests from the companies that are looking to do things that maybe aren't available in the in the standard packages, and you get to really be on the forefront. What do you think in terms of the value of a digital twin? Is it enough to just show data, or do you need to have the ability to do some prediction, to do some analysis, maybe some simulation to get the full value?
I would say 10 years ago, people were excited to see a 3D model and be able to manipulate it and see it. I mean, especially I'm talking about complex structures like oil rig or something like that, and just being able to visualize all these details was very exciting. But we passed that time, and people would like to see it as a model, as Erin said, live model of what's really in place or what's really will be in place, and also see kind of ability to predict how this model will behave in different circumstances. So from my perspective now, the requirements for digital twins are evolving into the direction of comprehensive model and visualization that combines design data, that combines building and construction data. I'm talking about AC and kind of sometimes cost data, scheduling data, and modeling IoT data, and modeling capability to predict kind of behavior in future, or kind of create what-if situations and test the unexpected situations, so to speak. I mean, rare situations. How does it behave in the hurricane conditions, earthquake conditions, etc., etc. So digital twin evolving. We are not there yet by any stretch of imagination, but people are understanding that if the real value of digital twin is to be as comprehensive model and representation of reality as possible, and it requires a lot of background collection of data and aggregation of data, modeling, as well as sophisticated representation of it and the visualizations that we hope game engines could provide. All this together really moved it to the next level. Okay. But people are realizing that's the kind of holy ground, holy grail of it. They're not there, but
right.
I think there is a market demand for that.
So let's turn it to the game engine companies, and I'm going to have the two of you talk about the role of game engines, and feel free to respond to anything that Erin or Igor said as well. But clearly game engines provide a richer, more immersive experience with whether it's a virtual product, whether it's something that's built, an asset like a building. But how do they really help with the design, engineering, sort of earlier in the life cycle, or producing, whether it's a manufactured product or whether it's construction? How does it help? How does it help with those processes, or is it primarily on the operational side? But I guess the question I'd like to ask is, why do digital twins need game engines, and what gap do they fill that engineering or IoT software can't meet on their own? I'm gonna go with David on this one first.
I'm going to be very controversial and say that not all digital twins need game engines. In fact, not all digital twins need a visualization aspect. And it's certainly what we're seeing come out of the market as well, where there are just instances where that glorified Excel spreadsheet is all that is needed, or a simplistic sort of 2D plan is all that is needed. And that's fine. I don't think trying to sort of force a 3D environment into a digital twin where it doesn't have a direct benefit or doesn't solve a direct problem is beneficial to anyone. In fact, it's only going to create hostility and slow adoption. Elizabeth brought it up earlier on, where the value of 3D in digital twins is all around spatial awareness and spatial assignment of data in context. So this is why it's a very sort of niche use case, where what project are you working on where spatial awareness or spatial alignment of that IoT data layer is crucial or helpful in the design or construction process. And you know, I can pull out some really rudimentary examples and say that, you know, for facilities and management, it would be, you know, there's duct E17205.B is malfunctioning. And instead of raking through floor plans trying to figure out where that is, you can hold up an iPhone and use AR technology to actually walk yourself directly to that location in order to identify it. Similar can be said in the design, construction, and the collaboration aspect of the built environment, where, you know, being able to visually represent where MEP ducts conflict with beams or have this kind of conflict resolution in a visual 3D context helps enable conversations and helps enable processes to move on. So it really does come down to what problem are you looking to solve and whether or not spatial 3D awareness is part of that.
Fantastic. And Elizabeth, when you and I met, you were in the manufacturing industry. I know we're talking about AEC and ACO a lot here. You know, what do you think in terms of you know, digital twins? Do they need gaming engines? And if so, where do they really provide the biggest value?
So I think that in many cases they do. I totally take David's point that if an Excel spreadsheet does just fine, why overcomplicate the situation? It's like, use the simplest tool you can to get the answer that you need as quick as possible. I think game engines do help because they do aggregate unlike data. And so I think if we look at the amount of data that is needed to make quality decisions over time, that's where game engines can shine, because it can take geometric data from multiple sources. It can take analytic data. It can take you know, IoT sensor data. It can take ERP data of employees and get all of that data and then provide that data in context. The other thing that can be done is they can be configured to respond in appropriately as things change. So I like to say that the value of digital twins is really dynamic digital twin, because when your data is changing and you're making a decision based on an old digital twin, it's not going to provide you a good decision. You need data that has a pipeline that can get you the answer that is current and that has data that has integrity at the time that you're making those decisions. So I think that the real value that game engines provide is allowing multiple data types brought together and analyzed. And then one more thing I'll say that was real quick is that it's I think there's a lot of value in history. So if you have a historical look at data and you're able to capture what you've done and then use it to predict the future and then see trends, then you're much further ahead by learning from what you've done in the past. So you can game engines can allow you to not only look at things in the moment, but also look at what was done and then predict what you should do in the future based on what's happening now. I think that's really powerful, and it's different in the digital twin space from what we've seen before.
Yeah,
I think it's also in the name. You know, maybe you know, I think we both kind of refer to our game engine the same way. Real-time rendering. You know, real time is there as a 3D representation that is constantly in flux and constantly changing. It's an environment built for digital twins where data is always changing, is that you need that real time aspect of it.
Yeah, fantastic. We're going to turn it back to our audience again, our participants, and ask another poll question. So if we can go ahead and pull that up. What I'd like to see, ask all of you, is what phase of the product or asset lifecycle can digital twins and game engines provide the most value? So the combination of the two. Is it sort of the conceptual design, the detailed engineering processes, the realization, whether that's producing or manufacturing a product or constructing an asset in the built world, or the operation phase? Or do you not see the value of gaming engines in this particular space? I'm going to give people some time to go ahead and put their answers in. Thank you. I see some great answers. We've got a good percentage of companies that or participants that are responding. All right, let's go ahead and bring that up. This one actually doesn't surprise me very much that that a lot of companies see the value in operation and being able to contextualize what's happening in a building or in a product, complex product, you know, or a refinery or something along those lines. Just being able to visualize and understand that in real time is so incredibly difficult, particularly when they are in remote situations. But it's not just operation. We're seeing that companies are able to make some decisions and get value in the conceptual and detailed conceptual design and detailed engineering, where there are a lot of tough decisions to be made. And maybe they're doing some simulation and some what if, and then also in the production or the construction phases, which is also very interesting. So a lot of value in different places, and I expect if we let people select more than one, we would see these numbers go up. That that people see value in multiple phases. So let's go ahead and move on. I think in fact, some of the questions that have been coming in are similar to this one. You know, we talked a little bit about the value, and we talked about how game engines can help, and that it needs, you know, we'd like to see it be more than just visualization, but that's valuable. But, you know, there's challenges. So, you know, many AC companies, operators, manufacturers are pursuing the digital twins, and we've actually seen in our earlier poll that companies are getting some really good success. But what makes implementing digital twins challenging? What's holding companies back from their goals? And what can the software industry, including game engines, do to help? Erin, I'm going to turn this one to you first. This is your chance to ask for your holiday list for how things can help. But let's start with the challenges, and then how can we get through them?
Yeah, I think historically with any new type of tech or process that we bring into the construction industry, there's always the challenge of just upskilling the workforce to understand what the tool is, how to use it, how to develop these types of assets to implement for their use, whether it's in the planning phase, construction phase, or management phase later on. So having those specialized roles that are able to really take on the challenge of developing, managing, and implementing something like a digital twin, I think, is a barrier. So I mean, the good news is that over time, just from what I've observed in my own role, is that these more special types of skill sets have become more and more prolific through the industry. So that is a plus. But I would also say another piece of this that's very, very challenging. There's also a significant cost, especially in the GC world, when we're looking at, what basically gets baked into the budgets to build or cut or whatever it may be. And a lot of times it comes down to convincing, the client or the rest of the team that, hey, this is a really good tool. It's going to be useful for everybody if we all buy into it. You'll even get to, have it as a takeaway if we, are able to do this right from the outset and potentially connect it to, your MEP equipment and things like that, so you can have more efficiencies later down the line. But yeah, it's just not that simple to implement yet. And I always tend to come back to the example of like iPads, for example, when they first came out in the industry. A lot of people didn't know how to use them at first. My own experience, just starting, I remember seeing a few superintendents using them as paperweights. So it definitely takes some time to like get that to be commoditized and get that to be just, you know, another skill set in your tool belt that you can pull out and just quickly understand how to implement and go with it. So that's my take on it.
Thank you, Erin. Igor, let's turn to you on this. I mean, what you get requested when people run into roadblocks, you know, and obviously Erin mentioned some organizational and training issues as well as others. But what kind of roadblocks are companies coming to you and saying that they need help overcoming?
Yeah, I mean, I would come from a different perspective. Erin is really kind of touching on the business side of it. We are mostly concerned with the technical side of it. And the most challenging here is this disjointment of different tools and technologies that are currently used in the workplace. And well, obviously individual software vendor do not help much because they hoard their data. They don't want this data to be reused. And we often see the situation where people come into us and say, hey, it looks very simple. Here, what we want to achieve, it's a simple digital twin, and you start digging down and see that data that they're trying to use is not connected. So the first thing is just to connect the data. And I think this is one of the biggest challenges is this data silos that all over the place. And for digital twin to be really useful and create a real ROI, it has to combine the data together. And the kind of game engine, from my perspective, is it's great focal point that can kind of open our eyes to this data. But unless this data is connected and unified, it's just a pretty picture, right? But without pretty picture, we cannot have a real adoption. But without real data, this adoption would not give us ROI. So it's two sides of the same coin. I would say that the jointment of data and technology is obstacles to creating effective and cost-effective digital twins.
Yeah,
I couldn't agree more. I would summarize it as the wish list of please integrate.
Yeah, and I think standardization will happen some over time. I mean, that's always the dream. You know, that is a moving target. Elizabeth, can you tell us what challenges you're seeing companies face, and how can we help?
Yeah, so I do see the data challenge, definitely. Somewhat the training challenge and like introducing new tech. But one of the sayings that I had in industry and continue to say at Unity is it's often not a technology problem. Like it's a people problem, a process problem, and adoption problem. And so some of the challenges are solvable with current technology. I'm not saying that everything is, but I think one challenge is that there's this FOMO, this fear of missing out with tech, right? So if you don't have this latest new thing, then the stable Excel spreadsheet, like from David's analogy, is actually good for what you need. But you're chasing this big thing that is complicated and misunderstood. And so the one of the challenges is adopting the technology in a very structured way that takes the company along on that journey, and they can see what the value is. Because what we see oftentimes is an unwillingness to share data between groups. And how can you build a digital twin when this group doesn't want to provide the data? Maybe it's upfront data that's needed for something on the factory floor or in field, and you can't get the data. And then companies trusting their partners that are developing the digital twin with the data. There are many issues that go along with just trust and just sharing of information between different areas. So if you find a problem in the digital twin up front, who fixes it? Who pays for it? So if somebody gets burned by that and they have to pay for something that maybe if it was found in the field, they wouldn't have to pay for. You know, there are, I know that's kind of a yucky example, but it's true. And I think that one of the challenges is adoption and then senior leadership in companies embracing at every level in all areas of the business. And so when that poll that you asked, is it early on? Is it in, you know, operations? Where do you see the value? They would all light up because that value would be seen at every point in the process, and you'd see how everything relates one to another. So yeah, that's I think it's data, it's people, and it's somewhat technology, but a lot of that's solvable.
Yeah. Great, and it's actually one of the questions coming in from the audience I want to come back and address that's related. David, if you would wrap us up on this one, what are the challenges and how can we help? I think you're on mute, Dave.
Sorry, I'm just coughing. I think Igor and Erin kind of set out the kind of baseline problem, which is, you know, data and getting started, and just that struggle of knowing how and where. I think technology does play an important role here. You know, if we were to look at the entry level for creating your own digital twin, say even a couple of years ago, you would have to have some form of coder or programmer to build your own custom links in from your databases into game engines or into your proprietary tools. It doesn't even have to be a game engine. You need data aggregating in a single source. It requires a level of technical expertise. This is why working with AMC Bridge is so great, because what they do is they're able to help create simpler bridges, and they're able to help create simpler connections. And that's our role here, is, you know, to try wherever possible, and we're not able to kind of lay it out on a sort of simple one-click digital twin solution, but it's certainly a priority where we should look to continue to strive to make it easier. And we're getting there. It's slow and it reacts off the problems stated by our customers, stated by you, Erin, and beyond, where the more we know about the roadblocks that you're facing in more granular detail, the more we can look to help try solve and address them. You know, if you look at, you know, providers like Azure and AWS, you know, 2 or 3 years ago, didn't have any digital twin products. They just had their IoT solutions. Azure now have their Azure Digital Twin platform, which looks to make it easier. AWS launched Sitewise and a couple of other platforms based on trying to get digital twins spun up quicker and easier by having these platforms. And similar with game engines, is we're trying to make sure that you do not need to have coding experience to be able to connect to databases. It should be a drag, drop, node-based system to be able to achieve it. So that's our role in this, to wherever possible, try to kind of alleviate that sort of headache on the opposite side. It's hard whenever the problem is so complex, like standardization of data and information, and comes from different ways. And I'm not even going to touch with a barge pole, people not wanting to share data, because, you know, that is a problem in itself and not for us to address. So yeah, we'll try and address it where we have influence, and that is really easy first steps.
Great. All right, we're gonna try something. This is a little bit different. I'm going to ask you, you know, I'm going to ask you to summarize in 2 to 3 words. Let's see who can do this. You know, there are clearly a lot of compelling value that we've talked about with game engines and digital twins. You know, it can be visualization, it can be analysis, it can be what if, it can be simulation. Collaboration is one that we really didn't talk about, but is one that I hear quite a bit. In 2 to 3 words, what would you say is the most important value that game engines can offer companies to help them get the results they want from the digital twin? Erin, I'm going to put you on. Oh, okay.
The good ones, Jim.
Go ahead.
You already covered all the good ones. Can we use your ones? Is that okay?
That's funny.
As long as you give me credit for it, then it just yeah. All right, Erin, I'm going to put Erin on the spot here. 2 to 3 words.
Yeah, ready. Operational excellence, predictability.
Oh.
Are my 3. Yeah.
high. All right, now it's back to you, Dave. Now that we've got the bar set so high?
And that is so high. What am I sure I can say about it?
No pressure, no pressure.
No pressure at all. I will go with experience. I think plays a much bigger role than we all really want to admit. I think the experiential side is important, visualization and simulation.
All right, so I heard experiential, visualization, and simulation. Out of all those words, I got the 3, so that was good. That was good. Elizabeth.
Real-time collaborative unifier.
Ooh, I like that. Real-time. You got 2 in there with a hyphen. Igor.
Well, I have to agree with David. According to neuroscience, 50% of our brain is developed to process visual information. So presenting information in visual form in dynamic and interactive is a key to kind of push the adoption on the top of real data. Coming back to, but I would agree with David's definition.
All right, thank you, Igor. Thank you all. I want to get to some of these questions. We have got some of the best questions that I've seen on some of these panels, so I'm going to jump us right into those. The first one that I see here is from Daryl Quam. I hope I'm pronouncing your name correctly. What lessons learned have the board members applied to help drive adoption of a digital twin? So what, in terms of driving adoption, what have you seen that helps drive it? And this, Elizabeth, I'm going to start with you because, you talked about the people side right about the same time I was reading that question. So.
Yeah, so definitely senior leadership, understanding the value because of the ROI that is enabled. And so those ROIs are really about understanding and predicting and preventing. And so I think that there is a lot to be done with digital twins that are related to the historical data that I talked about. And then, of course, experiencing and understanding that, and then using the benefit of hindsight, and then the benefit of like learning. So basically, like machine learning and applying the learnings from the past and the trends that are happening in the future. I think that is really a step toward adoption that senior leadership can really get behind. And I think only the highest levels of a company can embrace a holistic digital twin. And we haven't, I almost chose holistic as one of my words, because I think that it's true that getting all of the different disciplines to work together, they have to work together and they have to share and they have to provide their data and they have to like somewhat open up in a way that is not usually culturally accepted in so many companies. So I think having that adoption by, or that senior leadership support is one of the keys to adoption. And then the other one is seriously the tech and having something that can ingest all of this data, present it visually, present it in whichever form it needs to be consumed in to make the right decision.
Great. Oh, thank you. Thank you. And David, let's go ahead and send this one your way. I mean,
yeah, the best thing I can recommend just on top of that is concepts. Everyone is so focused on this vision of the future of what digital twins can be and the value that they bring and the ROI and instant sort of money back. And because of that, people kind of see it as either this too far off goal, which is very complex and hard to achieve whenever they haven't really even attempted to kind of prove even the very sort of basics. So can I get data set A to work with model B and present that in some kind of format? And I think what we've seen is these POCs end up leading to more investment and more funding from management whenever they can start to see small implementations working. because it is such a big investment to do this properly that you need to be able to have buy-in at each stage. You need to be able to understand and prove out the technology, and that's why POCs are just so unbelievably important for getting that buy-in. And it's definitely possible. POCs are simple to set up, so it can either make or break it right away.
Yep, strategic bite-sized pieces. Yeah.
Very good. Yeah, and I think you see a lot of companies try and jump levels of maturity and that they're not ready for. And I do think that moving up the maturity curve over time makes sense. Erin, what can we do for adoption? I imagine that's probably a big part of your day.
Yeah, don't give ops tech they don't like is a good one for starters. But really, it's about being strategic, making sure that the end user that is hands-on keyboard is really getting the value out of it and that they like it, which sounds pretty simple, but it's pretty powerful when you have stories or somebody who's boots on the ground saying, hey, I'm not going to build another job without doing this because this is the most amazing thing that has basically saved time, improved quality, whatever the case may be. So being really purposeful with how we're maybe doing those proof of concepts, getting the tech into the right hands of the people who will champion it, and then grow that organically through true value that's being driven from the ground up. Is kind of my take on that.
Good. Igor, I know you're less involved with implementation and adoption, so I'm going to start the next question with you instead, if that's okay.
Sure.
Unless if you're dying to answer that one, go ahead and answer that one instead. But
adoption, I think everyone kind of got in the point. But my point is start small, start on a POC, but start in a critical area because sometimes people are trying to replace what's already exists. And I would suggest doing something new, but on a small scale, and get management excited and adopters excited before going big. But kind of select the critical areas first, then the kind of secondary areas that are not as exciting to you.
Great. Oh, thank you, Igor. That's a great answer. All right, I'm still going to start with you on this next one. This is from Stefan Waite. How can design and construction firms ensure that digital twin data is accurate to what is happening in the field? And I would extend that, even to product companies as well. How can we make sure that what we've got in the digital twin actually matches what the reality of the physical twin? Igor, why don't we start with you on
that? I don't have any control of the real data. I mean, typically fed data, so whatever data I get, I use in out. I don't have a good question about it. It's more organizational, I guess, and it's technical, right?
I think you answered the question, though. It's the data. If bad data is bad performance, we see this with BIM. Bad BIM models lead to bad quantity, sort of costing data and coordination. If your BIM model isn't up to quality, then it's going to have operational impact. Same with digital twins. If the data is unstructured and unmanageable, you're going to lose accuracy. That's a key root of the problem of how you get that accuracy between visual digital twin and real sites.
Yeah, and there's also the aspect of changes in the field, right? If there's construction happening and a decision is made in the field and the data doesn't reflect what it was supposed to be, then that's a problem too. So I guess my thoughts technology wise is to implement some type of consistent matching, like using some cloud-based service to scan what you're doing and then match it with the data that you have. And if there is a discrepancy, flag it and then know it and then act upon it. So that type of just-in-time loop is, I think, would be very helpful in those types of situations. And in automotive, that happens a lot with, there will be a surface developed, and then a clay model is made, and then the modeler just kind of smooths this or does that, and it doesn't really match the math surface anymore. And so that's one of the tricks that is done, is that data gets scanned and then it gets compared. And if there are differences, they decide which way they're going to go. So that type of concept can also be and is applied in field, like in manufacturing. So it's just a constant reassessment and matching and, understanding what's different, and then making smart decisions, knowing that there's a difference, and then moving on.
A quick note on that, Elizabeth, I think there's definitely like that high-tech approach of like scanning, overlaying. There's a lot of software capabilities out there that do a good job of that. But also just with building construction, you can also just walk out to the site and look at it, take out your model and check. So we can also go low tech with it too, which is also an option I think we forget about sometimes, but yeah.
Totally. Yeah. The right tool for the job. What is it?
Yeah.
All right, I've got one more question here. I know we're at the top of the hour, so I want to thank everybody that's joined us, but I'll go ahead and ask this other question as well. This is from Dave Alpert. Could you talk about using digital twins as a design tool, simulating and testing future functionality and operations? Elizabeth, I'm going to put this one to you because I know you and I have talked about this. So,
yeah, I love that. I think that's one of the benefits of a digital twin. It's the dynamic part, it's the holistic part. It's allowing you to design very smartly. So, like one example of that type of strategy is applying, like creating some, I'll go back to my automotive roots, creating a vehicle design, and then figuring out what the manufacturing process would be, applying a manufacturing process back to the design to see if you can actually build it with the quality that you have spec'd for it. And you can do that without actually ever tooling the line, and saving, billions of dollars if it can. And so I think that there is a lot of validity and a lot of goodness in looking at a design in the context of how it's created later down the line, and then applying that reality check back, because that's where quality comes in. That's how things shine. That's how mistakes get prevented. So, and I think digital twins are the natural mechanism for creating that. And this is where immersion could come in, and high-end visual quality, with real-time ray tracing and global illumination and all that good stuff. Because sometimes seeing those details, the devil is in the details in those instances when you're looking at quality and reproducibility of product.
Also just quickly state that does exist. Also not going to get into the argument of whether or not a digital twin is a digital twin if it doesn't have real-time data, which means is it a digital twin until it's built? That's another discussion for another webinar. Have a look at computational design. Computational design does exactly that. It runs based scenarios for visibility, sightlines, solar, energy, a bunch of different information. The industry is already engaged in that design simulation side. And one of the big sort of feedback and areas that we hear from the computational side, with Grasshopper, with Ladybug, with all these sustainability elements of tools in the industry, is that its visuals are terrible and that they're not great for conveying or for presentation. But it does exist and it is used. They just have the same limitations and blockers that we've all discussed around digital twins today. Accessible, easy to implement, access to the data. It's exactly the same, just, we call it digital twin, they call it computational design, and it goes back and forward.
Good. Erin, you want to add anything there? All right, Igor, anything?
No, I mean, it's all been said well, so I don't.
All right, good. Well, I think we'll we'll take that just like we said before. You know, you don't have to implement technology to unless there's a solvable problem and something that's going to provide value. So I think we've come to the end here. I want to thank everybody for joining. Erin, thank you so much. David, Epic Dave, and Elizabeth, thank you for joining. Igor, thank you for joining, as well as for all the work that AMC Bridge and your team does to organizing these webinars. I think they're a great educational asset for people, and thank you for including me in it. That concludes our program. It will be, or it has been recorded, so it'll be available later if you want to share it with any of your peers or colleagues, or go back and review something that you may have missed. Thank you again, and we look forward to seeing you on the next one.
Thanks. Thanks for having us.
Thanks all. Appreciate it. Bye.